So this is going to be our second set of notes and ideas and concepts about mapping. Same processes as before. You can take down whatever notes you think you need. Write down whatever you think is important. And then at the conclusion of the video, we'll give you a short quiz, and you may use your notes to answer the questions on that quiz. First of all, let's recap what we've already talked about with mapping and consider this map which we've been working with. And what can we tell from this map? What we can really tell from this, what we use this for, is where places are. Is it in the northern or southern hemisphere? Is it in the eastern or western? And then we can get a little bit more exact and saying, it's 15 north and 30 west, or it's 30 south and 180 east. That's what this map can tell us. But let's look at the limitations of this map. What can we not tell from these types of maps that we may want to know? First of all, consider these two maps. Just pulled off of Google Maps. Two kind of random areas. We see we got some roads, and one of them we got some water. But the question is, are these two places similar or are they different? And we can't tell from this type of map. Here are those two locations. These are pictures taken at both of those spots, and you will notice the land that we would see in one place is very different than we would see in the other place. And being that this class is the study of the Earth and what it looks like, we want to be able to tell from a map what the Earth looks like. So let's start to examine some maps that can maybe give us a hint of what the Earth looks like in different places. Consider the map drawn differently. Here's the same location, the one that had the mountains, and if you look at that map on top versus the one at the bottom, you can see it's the same area, but notice the one on top. You get some sense that the land there is pretty steep, it's jagged, it's rugged, it's mountainous. So that map on the top tells us more about what the land looks like. That other location, well, the land was pretty flat, not a whole lot of relief or mountains or anything going on. And we can see the map at the top is really kind of similar to the one at the bottom because there isn't a whole lot of change in elevation. The land is pretty flat. And we can tell that from the map at the top. We can't tell that from the map at the bottom. What we're talking about here are what's called physical maps. A physical map is one that tells us what the land in a location really looks like. From here, we can see that A is in the mountains and that B is not. B is at a much lower elevation. We get that sense from the way this map is shaded and the way it's colored. We can see that C is in the mountains as well as A, but we can also tell by the shading and the way this map is drawn that the mountains at C are not nearly as big as the ones at A. With this type of map, we're looking at what the land is like under the water, which can be really important because we can't see it with our eyes. So this type of physical map tells us what the land is physically like under the water. That has a name. It is called a bathymetric map. It's a map that shows what the land underwater looks like. It's a type of physical map because it is telling us what the land looks like, just the land under the water. Now, one of the ways to describe the shape of the land that you can tell from these maps is called elevation, which is just how high the land is. And you can see these two triangles representing two different mountains. We'd see that one on the left has higher elevation than the one on the right. But the question becomes, how do we describe which mountain is taller? Look at these two mountains, two peaks, A and B. Which one's taller? It depends upon where you measure from. The person at the bottom looking at the mountain tops would see point B, the top of B, as being taller than the point at A. But if you were standing there, the person on the left is going to look at A and say, wow, that's really high, it's really up there. The person over there looking at B might not seem like the mountain looks as high, but in reality, the top of B is actually higher up than the top of A. So the point becomes, how do we describe, how do we measure elevation? It turns out elevation is always measured from the ocean. because the oceans are the same no matter where you are on the planet. Water basically lies level. You can't have water at a tilt. So the elevation of the ocean, no matter where you're at, is pretty much the same. So if everybody uses the ocean to measure from, everybody's going to have comparable measurements for elevation. Think about these two mountains on the opposite side of the ocean. You can't stand there and see both of them, but if you measure their height, their elevation from the ocean, it's a fair comparison to say which one is higher. The reason why we use the ocean is because, once again, water will lie level, and it's going to be the same starting point for everybody around the world. So, elevation is always described relative to sea level. You can be at sea level. That'd be like being at the beach and standing right there where the waves are coming in. You move uphill, you're obviously above sea level, and you can actually be below sea level. And you don't have to be underwater to be under sea level. Consider this, and this is a cross-section basically of California. We got the Pacific Ocean out there, and the land goes up and over a big mountain, and on the backside of the mountain, it's really, really, really low. The land actually lies lower than the ocean, but because it's not connected to the ocean, it's not filled with water. You can have elevations that are below the level of the oceans. If you go to Death Valley, you can see the sign there, Bad Water Basin. It's 282 feet lower than the ocean. You turn around and look at the cliff back behind you, and that's that picture on the right. Up on the cliff, they show you where the ocean level would be. Now, there's no ocean there because the ocean is on the other side of the mountains. If you were to dig a tunnel through the mountain to the ocean, this area here would fill up with water, and the water would be up to that point where you see that sea level sign. So a good definition, once again, of elevation is how high a location is above sea level. On a map, we need something to give us some numbers relating to the colors for how high we are above sea level, and that's what a legend or a key does. A legend or a key of a physical map shows us what those different colors are in terms of elevations. And you can see on the left-hand side, the dark green is generally the lowest, 0 to 250 feet, whereas you get up in the white colors, way at the top of the scale, you're way up there. You're 10,000 feet or more. Another example of map legends or keys can tell you what the land looks like, whether it's mountains, forests, whether it's a desert, tropical, or it's a city. They tell you what the land looks like. You all know that blue on a map represents water. And if you go there, that's what you're going to see in the land or on top of the land is water. Take a look at these two maps. They both look green. Really can't tell a whole lot about each one of these. Let's look at a picture of these two locations. There's a big difference. Now they both have mountains. One's not flat, but the mountains look differently because the one in the upper left that looked like that is in the desert. The one in the bottom right is here in Georgia where there's a lot of trees. So sometimes a physical map tells you what's on top of the land, whether it's a desert or trees, whatever. So think about this, percent tree cover. This tells you how much of the land is covered by trees. So if you physically went to that place on this map, you would see a certain amount of trees. It is a physical map because it shows you what the land physically looks like. We will be talking a lot about weather and climate maps, and they're kind of a type of physical map because they do tell you what's physically going on. A weather map shows you what the current conditions are. This can be how hot it is it raining, sleeting, snowing, are there clouds, is it windy, or is it stormy? Remember, these are all physical things that you would actually go and you could see or experience there. So these type of maps measure physical conditions. These are a kind of an offshoot of physical maps. Now, as opposed to a weather map, which tells you what's happening right now, you could also have what's called a climate map, which shows you the weather trends, the places where it's generally hot or generally cold. It might not be hot or cold right now, but it shows you the averages. There's an expression that we're going to use in this class that climate is what you expect and weather is what you get. You would expect it to be hot in Florida. It doesn't mean it can't never be cold in Florida. That would be the description of the weather. But the climate in Florida would generally be described as being hot or tropical. And climate maps show you the kind of general averages, whether it's temperatures like this one or rain. Where does it rain the most? That's a climate map. That's a part of the average weather conditions. It can also be wind. Where is it windy? Where is it not? That's a physical condition that's related to the weather. And a map can show you those conditions or the averages of those conditions. Some other key components of maps. You have what's called a scale. A scale tells you the size of the map. What does 1 inch in that map represent in real life? Looks something like that. Now a compass for us is important with latitude and longitude because it looks like that and it tells us which way on the map is north, south, east, and west. Finally, a legend or a key describes the objects or colors that are shown on the map. So once again, once you are finished summarizing these notes, pause the video, put your phone away, come see me, and we'll get you the quiz that you can use these notes on to answer the questions.